Okay, so here we go. We're getting ready for part 2 of the project. So we're going to come in and you've completed the module 1 project. You come down to the bottom of module 2 and this is where you will submit the module 1 project. Okay, this is where we're going to get the information for the new module 2 project. And I'll open my template. Have it ready in the background and minimize that. And then I want to get the guide. And this is my instructions and tells me what to do. Okay, so we're going to be using the ultrasonic sensor to calculate the velocity of sound, which should come in at 343 meters per second. We're going to use a measured distance and the time it takes from the serial monitor read-in to determine what we calculate for the velocity of sound. Okay, so step 1 is connecting the ultrasonic sensor to the board. You can see here in the picture. Okay, so if you place the sensor on the board facing forward, then the pin on the right hand side on the back will be the one you use for power, and you run it to the red strip. Then the pin on the left, you use a black wire and run it to the blue strip. Okay, once we get that wired in, then we're going to go on to the next step, which is running the trigger pin to pin 7 on the mega board and the echo pin to pin 8 on the mega board. Okay, and you can see here the white wire is connected in to the hole next to the red wire. Kind of looks like it's in the same hole, but it's not. There you go. You can see those are in 2 separate holes. And then the white wire comes over here on the mega board to pin 7. You'll see the pin numbers down the side. Put it pin 7. And then the blue wire is to the left on the right to the ground, to the right of ground. And the blue wire runs to pin 8 on the mega board. Okay, so over here, let me see if I can close in on that a little bit so you can see the white wire going to pin 7 and the blue wire going to pin 8. Okay, so now we're ready to upload our code and open the serial monitor. Okay, so I'm going to launch the Arduino app. Plug my board into my USB port. And you can see my setup here now. I have my object, and I've got my object out at 20 centimeters. Here's my ultrasonic sensor. The tip of it is facing the object, and my ruler is here in between. Okay. So I'm starting out at 20 centimeters. I'm going to double that and make it 0.4 meters. Double that and convert it to meters all at the same time. And I want to come here and open my serial monitor and then upload my program. Okay, I don't know how I forgot this, but we have to hook ground to the board here from the ground strip on the breadboard. And also power goes to the other side where it says 5 volts or 5V. That one goes to the red strip on the breadboard. Okay, so you can see once I got it steady and everything going, it comes in right at 1225 each time. Okay, this is my round trip time. I want to convert that into seconds. So that'll be my 1225 EE exponent -6. Okay, so my calculator, I'll do 0.4 divided by 1225 with an exponent of -6. And I get my 326.5. I'll do 4 more of those at these particular distances, record the time, and come back and calculate. Okay, I have my data here, and I need to copy it onto my PowerPoint. Here. All right, so what I'm going to do is copy these few columns from here. And come paste them on my spreadsheet. Okay. On the next page, they want us to do an average. All right, so my numbers were, and I'm going to split screen here to make this easier on me. So 326.5. 331.1, 348.8, I could zoom in and make this a little easier on myself. I'm at 39% and 34, 344.8. Now I'm going to add all of those values together. and divide by 5 to get an average. And my average comes out 342.9, which is not too far off from the 343 that it should be. So now to calculate the percent difference, okay. I'm fighting with the computer, 1 second. And my V average was 342.96 as opposed to 343. And then I'll divide that by 343. All right. So 342.96 minus 343. And we take the absolute value of that, divide it by 343, and multiply by 100. Since I've already multiplied by 100, this is a 0.01% difference. I would not need to multiply it again. That would make it a 1% error, and this is not a 1% error. It's too close. It's a 0.01% error. Okay, then there's a couple of questions down here for you to answer. We didn't have a lot of errors. It was pretty precise. We could look at where it was more precise, where we got closer to 334. Was it the extended ranges up close? It was not quite as accurate. But out at a distance, it was reasonably accurate. Okay, so this particular lab you'll submit in Module 3. So it's due by the end of week 3. So we come down in modules to the bottom of Module 3, and this is where we'll submit the lab we just completed. Thank you, and let me know if you have any questions.